response video to Holiday on the subject of this. I was calling it Planetary Light Aberation. Really not on this subject. Yeah. And it's, well, I'll get to it. Well, now I might as well just start with it and then we'll move on. I mean, it says right in the document, that, this does not include the effects of the value above. The values in the above table exclude the effect of light time correction. So right there, they're conceding the existence that you need to do corrections. In other words, we consider the position of the plant at the moment when light is emitted by the source instead of the location of the plant at the moment when the light reaches the observer. So they're obviously conceding it. They're conceding that where it looks like it is isn't where it is. We don't see it where it is. We see it where it was. So this I shouldn't even have to have this conversation. I mean, with that as evidence. So this is obviously some sort of gravitational momentum-y thingy that has very little to do with the subject of whether or not light can carry more than one momentum, which is the subject. So anyway, I'll play this little clip and then I'll do some stuff.
To this video. The thing is that's hard with physics as you progress is that sometimes it's difficult to let go of those naive understandings that one might get from high school.
Yeah, this is so patronizing. If I prove you wrong, then what? Can I call you naive for the rest of your life? I'll just keep referencing how you never really got it and you're stuck in some naive notions of blah, blah, blah. I mean, it's just, you can't see how, if you're going to sit there and tell somebody they're naive, that they have notions, okay, that's just overtly offensive. I mean, I was calm. And then I played this and I'm like, fuck you. What are you, you was some kind of asshole? I don't know what naive is. I don't know that, yes, maybe high school I wasn't taught everything, but guess what? In high school I was taught, okay, that light is old. Okay, when we see a star in the sky, that star could have supernovaed. What we're seeing is old light from an old location that has nothing to do with where the star is now. Do you think when we look at the stars we're seeing where they are now? That their momentum was carried through? No. So you're the one with the naive notions that somehow the idiotic thought experiments they're using for this idiotic time dilation crap have something to do with reality, when they have nothing to do with reality. You will never have a spaceship shooting light at a mirror going half the speed of light and hit the mirror. You won't do it. Ever.
From high school, we're told that everything is bouncing balls. And you have to be prepared that maybe...
I guess I wish that's what I was taught in high school, because guess what? That's what it turns out to be, okay? I wish they would have told me it's all goddamn fish, okay? You can call them photons, call them fish, doesn't matter. They're things moving the speed of light, period. And there isn't anything else. Everything else is just an arrangement of the fucking fish. I wish they would have told me that.
Maybe everything isn't bouncing balls.
Yeah, again, okay, well, let's do the ball thing then. Okay, let's just point out where this argument is and why it exists. And I'll try to just calm down. Alright, so, look, I'm making the simple argument that if, I should have picked a different planet. I don't know, I should have picked stars. It's just hard to do because we're in this whole orbiting thing, and that does screw up these conversations. But the point is that I think this is kind of a known fact that Newton became smarter, okay? The Newton formulas became better when they figured out that light travels at a speed, that it's not instantaneous. Because they had all this observation data, and when they changed the observation data to account for the fact that some of the planets they were looking at took 20 minutes for the light to get to them, okay, that their observed locations weren't exactly accurate, that they became more accurate when they added in the change in location relevant to the observation. So I mean, it's already. I mean, in essence, I think that's just a demonstrated, provable fact. Okay, that we're not seeing the planets where they are now. We're seeing them where they were. The light doesn't move with the planet. It doesn't contain the planet's momentum. It doesn't have any momentum except its directional momentum. Period. All right. So the real way to understand this, I think the simplest way to understand this, is to go back to the train thing and a guy throwing a baseball. Alright, so there's a guy on a train. I should make a bigger train. Let's just say he's on a train car. The train's going 90 miles an hour. Okay, the guy can throw a baseball 90 miles an hour. Now if he throws the baseball this way, okay, at 90 miles an hour, the train's going 90 miles an hour, the baseball, everybody's going to understand, it's going to go 180 miles an hour to somebody catching it outside the train over here. So if he throws the baseball to a guy standing over here, and the train's moving 90 miles an hour, he throws the baseball at 90 miles an hour, it's going to cut to that observer at 180 miles an hour. So there is a combination of momentums. Okay, the thrower and the train will create a higher velocity. Now, if he shoots a flashlight, though, that isn't going to happen. Right? So if he shines light, the light's going to leave him at 186 miles a second, period. Alright? It doesn't matter how fast this train is going. It's irrelevant how fast this train is going. This train can go a zillion, gazillion, bazillion miles an hour, and it's not going to matter. The light is going to leave that flashlight at 186,000 miles a second. And that's period. That's it. There is no conversation. And likewise for going, so that's it, going forward direction, so the same holds true. So with the baseball player throws the baseball off the train, you have a combination of vector momentums. Okay, you have the momentum of the train, which is 90 miles an hour. You have the throw, which is 90 miles an hour in this direction. You end up with this Pythagorean hypotenuse direction. But if it's light, the light does not do this thing. It doesn't have this component of momentum. So it does the same thing it was doing before, which is it goes in this direction. It just goes in one direction, 186 miles a second. And that's all. And so this light is not going to travel like this. Okay? You know, and catch up to the guy here, so this guy will see the baseball thrown here, okay, as if this is where the guy actually threw it from, when he threw it from here. He's not going to see the guy here. This is the only path that is possible. And so say if this was like a smiley face being broadcast, right? So the smiley face here, and when the train gets here, it's a frowny face, okay? I mean, by his argument, when the smiley face gets here, when the light finally gets to the observer here, say this is 10 minutes, and every 10 minutes it switches to a frowny face, he's saying we're going to see the smiley face here when the actual face is now frowny face, because it's 10 minutes later. That isn't going to happen. Light travels in one direction, no vectors in any other direction, no momentum in any other direction, no nothing in any other direction. If you did do that, then you could shine a light at a 45-degree angle off this train and have some expectation that what? The light's going to travel 267 miles a second? No, it's not going to do that. It's not going to pick up the momentum of the moving train. It's not going to be, you're not going to be able to add any vectors. There's no vectors. There's just direction, period. And so I'm just saying the thought experiment of the light clock is nonsense. In a spaceship going half the speed of light. Again, if the spaceship's going half the speed of light, and you have 1 foot between the clock and the mirror, then every time you go one cycle, 1 foot, this will travel 6 inches. So every time you go to hit the mirror is going to be 6 inches away. The light can't possibly do it. It's not going to go like this and hit the mirror. It's just not. You'd have to aim it in that direction. You'd have to sit there and prearrange it going forward. Do you think the light from Venus is figure it out ahead of time. Oh, I have to shoot way forward so the guy on Earth can see me in the right location. No, not happening. That was quicker than I thought. Alright, I'll move on to this other part. Well, let me play this a little further.
So you have to be prepared that the apparent image of Venus and the principles at play might not be wholly described in that simplistic assumptions and models as you amend them.
Again, so now it's simplistic. So it's high school, silly high school notions. And now they're simplistic. You know, I'm just saying, what would you expect if I described you as high school and simplistic? You'd take that as what? A compliment? You're stuck in high school with simplistic notions? And somebody's not supposed to react to you with, fuck you, asshole? Especially when you're fucking wrong. I mean, you're going to be proven wrong. So you're sitting here insulting somebody when you're wrong. And you're using derogatory, patronizing rhetoric. And somebody shouldn't just say, fuck you.
Just put forward. Indeed, they're not. The thing to look up, as I've found, first of all, I looked up apparent position of planets, and everything I got there was to do with...
Look, you don't have to look up anything. Just look at your own document. The values in the above table exclude the effect of light time correction. Light time correction. Light time correction. Fuck. They're conceding the existence of its necessity. They're conceding that you don't see it where it is now. You see it where it was then. How else to illustrate this? Light isn't, light is the quanta. It doesn't, it's not matter. It's not something that can acquire velocities by illusion. The matter itself, I'm saying, is still all the little pieces. You throw a baseball, the photons inside the baseball aren't going faster than the speed of light. No, each one is taking a turn, going a little bit in the direction that the baseball moves in. Each one is taking its little share of taking one little tiny step in that direction the baseball's moving. And we don't get it because we don't understand how fucking fast 186,000 miles a second is. How many fucking goddamn steps goddamn photons are taking in one fucking second? They're taking 186,000 times how many steps would be in a mile. You know how many fucking photon steps there are in a mile? I mean, there's got to be like a zillion photon steps in a goddamn mile. So it's 186,000 times a zillion photon steps per fucking second. That's what the goddamn photons are doing. And so 90-mile-an-hour baseball is nothing for a photon. That's like, there, it. They did it. They're done. They're done working for the day. They go, there, they're done working for the day. They did a 90-mile-an-hour baseball. Nothing for them. Anyway. Alright, we'll get to this other patronizing, obnoxious part maybe.
The problematic feature out the apparent more...
Oh, good. A break. I'll be back. Ah, okay, leave us continue, finish or something.
Of the planets have the loop in them from our perspective.
Right. So yeah, another thing to talk about was, you know, even if I was to use this argument that, you know, and I think it's a valid argument that you don't see the actual location of where something is, you're seeing where it was. But even if we saw the actual location, even if this momentum thing, as you say, worked, and things could actually have a momentum, part of the problem would be is that, say if I was sitting an observer here, and I'm watching this planet moves from here to here, and So we're just talking about the fact that, let's say there's a 10-minute delay in the light getting here, and in 10 minutes the planet moves to here. So it's an exaggeration of how the actuality would be. But so this is 10 minutes of time. What would actually, if you're going to argue that this light somehow bends to come in this way, so I see the planet where it is, the real point would be is that if it had the momentum of its velocity vector would be somewhere around here. So I should be seeing it wrong still, but wrong in its vector location without gravity. I mean, obviously the light shouldn't be able to anticipate gravity too. I mean, you're really asking the light to be awful intuitively brilliant to be able to figure not only where the planet will be, but to figure out, that gravity is bending its momentum. So obviously the momentum of this body is in this direction, so the light, if it was going to go forward, would have to be going forward from that vector. So the loop would have to be like that, or however you want to try to say that this light doesn't go this way, somehow this light comes from this direction, which I'm sorry, it's a ludicrous proposition. You're not seeing the future, you're not seeing the present, you're seeing the past. Whenever something is more than I'm trying to think of the 186,000 miles away would be 1 second, right? So it would have to be, it would have to be like 1,000,000 miles away. So as soon as something's 1,000,000 miles away, yeah, you're seeing where it was, you're not seeing where it is. The other point to make is, he pointed out to some, it's a 30-minute video, so he does some different things, but he was pointing out the velocity of the observer, and the observer's velocity for this circumstance is irrelevant, because the observer, we're talking about a tiny period of time, 4 seconds of observation. In 4 seconds of observation, there's not going to be any need for me to worry about any of this crap. If I was taking time exposures of some distant star, well, then I got to worry about moving my telescope and changing the angles because of the rotation and velocity and all that kind of crap. But for a 4-second observation, I don't have to do any of that stuff, so it's kind of irrelevant what my velocity is as the receiver, in the sense of, as long as well, even if my velocity is towards it, all I can do is blue shift it if I'm moving towards the thing or away from the thing. I can only change the period of the light. I can't change the angle of the light as an observer. So let's jump to this. Well, I'll play a little more, see if there's anything else.
The true concept is about to look up is the aberration of light.
Yeah, I don't think that's the true concept. I think that's the aberration of light has to do with lensing. It's not. This doesn't have anything to do with time and distance. It even says in there, it doesn't matter how far away the object is, it would be exactly the same effect. Well, obviously, what we're talking about, the effect would be increased dramatically with distance. Obviously, the stars that are 15 billion years away from us, we're seeing 15 billion years into the past. We are not seeing their current location or anything even close to it. They probably did supernova. They probably are, it has nothing to do with current universal reality, what we're seeing at the end of the universe, 15 billion light years away. So anyway, yeah, so I'll move to 30 or something. I think he did some kind of cranky crap. It's some kind of bold crap or some sort of crap of some sort.
Stood this in terms of, but it's clear to me that they're discussing that everything I've said has been true and confirms my hypothesis that the kind of high school simplistic view of it is far from.
So he did it again, and this image here it should be understood. They're saying there's more distortion in the sun than there is in Venus. So here you have the sun in the center of the solar system has, is creating this entire distortion. This isn't a Venus, this is the sun, and Venus is a shadow on the sun. And the distortion's being created by the fact that the sun is out of position. Not that Venus is out of position, the sun's out of position greater than the amount of position that Venus is out of. So how could this possibly make any sense to somebody? The sun's moving at a faster velocity than Venus? Relative to the Earth? Come on. I mean, come on. Get serious. Yeah, so I mean, there's no point in doing this. I mean, you're talking about movement of the observer. The observer's movement is irrelevant. This is all observer distortion, mostly. This is not distortion created by the fact that light takes time to get here, and that you can only view the past when something's very far away. So anyway, high school. Fuck you.